Black holes, and especially supermassive black holes, are some of the most important objects in the universe. Studies have shown that especially the big ones drive the dynamics of galaxies more than just about anything else, because they're both very large, sit at the centers of galaxies like gravitational anchors, and also because they fill the galaxies full of hot radiation. They've been studied a lot, and what's interesting is there have been several in the last decade that we've discovered that are much bigger than anything ever thought possible. Several billion times the mass of the sun, formed in less than 1 billion years. We believe black holes come from stars that have collapsed. And so we know the masses of the stars they came from. And there's a speed limit at which the black hole can grow. And that speed limit precludes them being so big so fast. The mass of the black hole has a speed limit known as the Eddington limit. Stars themselves do not have the same speed limit in terms of how fast they can grow. So there was a question, could you find a place where a star might be able to grow much bigger than typical stars grow? We decided to actually take this idea, make a simulation, grow the star to the size that people think might be possible in certain configurations, and see when that star collapses to a black hole, can it actually create the types of supermassive black holes that we see in nature. What our paper shows is if you do start with this model, where you can have a special situation where a very massive star can form and then become a black hole, that we can produce the types of things that we observe in nature in many different respects. Here at Los Alamos National Laboratory, we have the unique opportunity of having the codes, the physics packages, and the supercomputer facilities needed to do this detailed calculation. And we've seen that when you throw it all together and you take all the algorithms and other things that we've developed over the years here, that we can replicate some of the more interesting things that we've seen in nature, driving the dynamics of the evolution of the universe.